Assalamu alaikum ji. This is Dr. Muhammad Aman Aslam Khan, and this is the course of numerical methods. And you're currently in the 5th semester of the chemical engineering. So, and there is some in this first lecture, we will be trying to see what are the requirements of the course, the general introduction, what we are expecting from you. But before I start this, I have already shared with you the course contents, the detailed course contents, week-wise plan, and all the requirements of the course. But in this lecture, we'll just try to go through all those information and specifically the motivation of this course, why are we going to learn this course, what are the benefits that we're going to get from this particular course. Okay, and if you have any question, you can raise your hand, and obviously we will be responding to you. Okay, so the course code is math 351 numerical methods, and it is the not the lab is involved, but we will be doing certain portion of the lab. Okay, so the objective of this lecture is just to introduce you to the contents, and we go through the relevant problems maybe from your chemical engineering courses, which are necessary in terms of solving, and how this course will help you solve those problems. Okay, so general information, there is a prerequisite of this course. There are two prereqs. First is your math 101, that is a calculus 1 course, and then you have a linear algebra and ODEs. Okay, and in terms of lectures, there are certain lectures in which we will be recording those lectures before we coming to that class. We will upload those lectures on your portal LMS, and our motive of those courses, those classes, will be actually the discussion mode or the problem solving mode. So lectures will already be available to you in some of the lectures, and we will be just coming into the class to discuss the problems relevant to that particular topic. Okay, so that actually procedure will be called a flipped classroom mode. Okay, so the lectures will be otherwise in the normal routine. We'll be just doing the lectures as we do in the in class sessions. Okay, and in terms of general assessment, you are already familiar with the system. There are quizzes, assignments, midterm, and semester exam. We also be including a group project in this course. So there will be some problems we are going to upload on the LMS and some other platforms. So you can make a group of certain people, and at the end of this course, you'll be submitting a report on that particular problem. Okay, so that will be a group project. It will be graded, and it will approximately contain 5% absolute marks. Okay, and otherwise it's just the quizzes will be, as you know, what is the routine, okay, and what is the frequency. Just to reiterate, we try to have as we have a 3 credit hour course, we try to have 3 to 4 quizzes. Okay, and the assignments will be group assignments in terms of a project, and then we have an individual assignments. Okay, and your assignments will be uploaded on LMS. We will not be taking any handouts, okay, in terms of so they will be uploaded on LMS. Okay, so coming towards some general information. So as you're uploading the information on LMS, so you are actually the author of that particular submission from your account. So you will be responsible for that writing. So if we found that that writing has been copied, or it is being taken from somewhere without the reference, so that will come into the uh, issue of plagiarism, and we will be seeing that. Okay, so in the course outline I already shared with you, you can go through the policy, the plagiarism policy. Okay, how that going to work. And and then the attendance. The attendance is actually from the university. You have to be here for the 75% of the lectures. But I'm expecting that you'll be here for all the lectures in which there is not any particular emergency. In terms of maybe some videos from other sources, or some simulations, or some informative value, or assignments, all the information will be over there. And we also be taking the quizzes from the LMS. Okay, so it will be the quizzes will be taken in the lab, so it will be an online quiz, so that will also be happening on LMS. Okay, so we'll try to use that particular platform to maximum communicate with you. Okay, so you already have my email. I have sent you from my emails some information. My office is 209. There are some contact hours written over there. You can always come to the room. You can ask question if you have any problem. Okay, we can also arrange some problem sessions. Okay, so if for example in particular topics we are lagging in terms of some problems, so we can arrange some problem sessions too. Okay, so this is the general information. And now coming to the textbooks, uh, can you please turn off this light, maybe possible, maybe it's more visible to you. Just this one, try. Yeah, I think it's better. So so there are one textbook that we are following, and we will be regularly following the reference books. I have already sent you their PDFs. Okay, so this is the introduction to numerical methods. It's a MATLAB approach, and the reference book will be the numerical analysis. Okay, I've already shared the copies with you, and you can just follow the contents. With the contents will, I'm going to give you what are the readings that you have to do before any particular topic. Okay, so there will be a plan that I'm going to share with you before every lecture, that this is the readings that you are supposed to read if there is any, or these are the exercises that you can go through for the particular topic. Okay, so coming next, there will be let's start with the one of the actually a very familiar equation from our very school days. Okay, but try to see how it is important in this particular lecture. So we'll be getting into now the contents of the lecture. Okay, so uh, consider this second degree polynomial, x squared minus 2 equals to 0, and we wish to find the real solution. Okay, we're interested in real numbers. In this particular course, we will be interested in the real solutions. Okay, means real solutions mean in real numbers. Okay, because we know at times we also get the complex solutions. Okay, so in this particular course, we will be focusing on the real solution of a problems we're going to go through. Okay, so if you see this particular problem, x squared minus 2, maybe you're solving any particular problem, a physical problem, and you come up finally to this equation, and maybe this is the length of a certain, maybe a very sensitive wire. Okay, so x is a length in terms of meters, maybe if the units are meters. So when you solve it, obviously you say, okay, we will only have to get the positive root because it's the length. So root 2 is the solution of this equation. So when I say root 2, it means, what does it mean? It is some real number, but root 2 is just the representation of a certain real number. Okay, root 2 is nothing. If I need to quantify what is root 2, obviously root 2 is a representation of a certain real number. Okay, so when I that we usually use the calculators. So if I plug root 2 in my calculator, and maybe I wish to cut a wire of that particular length, so I need to know what is root 2. So it gives me this representation. If you go to the normal calculators we have, so this is the number I get. Okay, so if you count down how many decimal places we have in this representation in a calculator. So there are 3, 6, 9, 10, 11. So one is there. So there is a 12 decimal places representation. Okay. Um, in terms of computers, okay. So after the decimal we have 11 digits, and before a decimal we have one significant digit. Okay. So that is the representation, and the calculator round off the value of root 2. Actually, just take that representation up to the 12 12 digits. Okay. So it means this is actually, the sign over here is that it is not an equal, it is an approximate value of x up to certain decimal places. Okay. If I ask you what is 1.414, you'll say it is, for example, in this scenario, you'll say that it is the approximation of root 2 up to certain decimal places. Okay. So it means whenever you wish to use the exact value of a root 2, you can't do that. Okay. You have to use a certain representation of a root 2 in terms of decimal places, either 2 decimal, 3 decimal, 5 decimal, 8 decimal, 10 decimals. Okay. And why we are discussing this is the reason is this, because we will be using the softwares to do the mathematical problems arising in engineering. We try to use the softwares. In this course, we will also be using the softwares. Okay, we'll be using the MATLAB. MATLAB is a matrix laboratory. I'm not going on that side now, but we will be using MATLAB. So whenever you store any information into the computer, computer does not understand our normal arithmetic that we do. They convert those digits into the binary system. Okay, so they convert that information into the binary system, and they understand that information through those binary system. Okay, you have learned in your basic computer courses how the number is being stored into the binary system. Okay, so there are 3 portions. I'm not going over there, but the computer understand the binary system, the 1 zeros. Okay, so they understand. So whenever, and they have a finite space. Okay, when you say we have a space of a 16 GB or 1 terabyte or 2 terabytes, so you're talking about a finite space. Okay, so there is a finite storage space in computers. Okay, so that's why, and our problem is in real number system. Okay, so there are numbers in real number systems which are not finite. The representation is infinite. And what are those numbers? The irrationals. Okay, so the irrationals are the real numbers of which we do not have the finite representation, like root 2. Okay, root 2 is an irrational number. Root 3 is an irrational number. So square root of any prime number is an irrational number. Okay, pi is an irrational number. Okay, so these are the famous numbers, which are irrational numbers. Okay, and they are somehow deeply connected or actually concentrated in the real number system. So real number system is what? It is a combination of rationals and irrationals. What are rationals? Which have finite representation. And what are irrationals? Which have infinite representation, which doesn't have a finite representation. So whenever I have a number which is infinite and I try to store in a computer, so computer can't do that. Computer can understand that number up to certain decimal places. Okay, up to 15 decimal places, up to 30 decimal places, up to 100 decimal places. Okay, so as we keep on increasing the efficiency or storage of systems, so that is the computers can do. Computers can, by the way, understand up to normally up to 15 decimal places. Okay, or 30 decimal places at max. But this is the limitations we have. Okay, that is also a very high efficiency in terms of efficiency. 15 decimal places is a very good efficiency. Okay, but still it's for example, if I'm not going up to the 15 decimal because it requires a lot of maybe computation or storage, so I'll go up to maybe our solution up to 2 decimal places or 3 decimal places. So obviously I will be rounding off this number up to 3 decimal places or 2 decimal places. It means I will be very much away from the root 2, from the original number. Well, I say very much away. After 2 3 decimal places, that will be not the same number I'm using. Okay, so the computers have limitations. That's a problem over there. So you see, a solution of x squared minus 2 equals to 0 gives a solution, which solution is not being stored in a computer after certain decimal places. Computer is not able to understand what is root 2 after certain decimal places. Okay, so this is the limitation of the systems, computer systems, when we use them. Okay, so now after one actually challenge that I just pose, by just taking a simple example. Okay, now I'll be moving towards actually what will be the contents in this course we're going to cover. Okay, so you have seen in your basic courses of the mathematics, from the college days, from school days till the university, you have learned that you are solving the equations. It's a simple thing, you're solving equations. So that equation is a representation of a certain physical phenomena. Okay, now that equation can be simple polynomial. Maybe it is not a polynomial, it is some other equations which contains other functions, special functions. Okay, so still, if you see this particular equation, it involves a variable t. Okay, so this equations actually, so if I read the problem, this problem is about the temperature in the interior of a certain material. So that actually material is embedded in certain heat source, and this is the equation that we get. Okay, and we wish to find this t is small t is a representation of a temperature, and we wish to find the temperature. So it means we need to solve this equation for variable t. Okay, so you see, only unknown is what? T. Okay, temperature is only unknown, and this is a one variable equation. We just seen x squared minus 2 equals to 0. It is also a one variable equation. Okay, but the difficulty in this case is a bit more as compared to x squared minus 2. Okay, so what actually I was saying that whenever in the previous courses you have learned, or in any chemical engineering course you're learning, you come up with any equations that you need to solve. Those equations are maybe only one variable equation, they can be system of equations. Okay, and they can be differential equations. Okay, so these are the difficulties that may, or these are the equations that arise in in the problem, physical problem, when you are solving them. Okay, so if I start with this particular problem, in this particular problem, what my aim is? My aim is to find the value of t. That is a basic. I wish to find that t. But up till now, we are not aware of very much methods which solve this equation. We majorly learn about the how to deal with the polynomials. Okay, maybe how to majorly with the polynomials, we have some quadratic solutions or maybe some cubic formulas. Okay, so there are some maybe manipulation we can do to try to find that. But in this particular course, our first topic will be how to solve a one variable equation. It's actually any equation. If it involves one unknown that is in this course, then how to solve those equations. Okay, so in this particular problem, we'll try to find the temperature T. In the coming up lectures, we'll be solving this particular problem. Okay, so this is the first topic, or in terms of content, that we're going to solve, and it says a solution of a one variable equation. Now if I ask you, is this T be, if we wish to try to find the solution, uh, what is the possibility? because we wish to find a real solution, either we're going to get a rational or an irrational number, the solution. It will be some rational or it will be some irrational number. If it is a real solution, there will be only two options. Okay. What you maybe infer from your previous knowledge, what possibility will be there in terms of a solution? So, we have an option that it's a higher possibility. It is a higher possibility that the solution will be irrational, because the equation is a very much complex in terms of exponential, and cos hyperbolic is also a combination of an exponential function. When you say e exponential, e is actually an irrational number. It's already an irrational. It's an exponent. So exponent is already an irrational number. Okay. So this equation involves exponents. So whenever we try to find the value of t, it will be some combination of some exponents. So if there are exponents involved, so we'll be obviously looking at value of a temperature up to certain decimal places. Okay. So it means the solution is a higher possibility that it will be an irrational solution. Okay. So we'll see that how to solve such equation. So this is our topic number 1. Okay. So moving to the next problem. So this is a mass balance problem. So there are certain inflows and outflows you'll see. Okay. So there are some inlet and we have an outlet, and we wish that we can find the outlet from different streams. Okay. What is the value of certain maybe gases at outlet streams? In particular separation system, there is a certain separation, and after that separation, how much separation has been done. Okay. So we are interested in the outlets. Okay. So the outlets you see is on the top, it is called F2, or maybe a second outlet, and then we have fourth outlet and the fifth outlet. Okay. So we maybe wish to find what are the values of values at the outlet. So the system that we actually develop, the mathematical problem that we develop from this problem is, from this mass balance problem, is, you can see at the end. Okay. That is the problem that we get. Now this is the problem of a system of equations. So there are certain system of equations. So there is W12, W11, W14, and W15. Okay. So we know the value of W11. Okay, W21 and W31, these are the inlet values. So we know them, but the unknowns are actually W12, W14, and W15. Okay. So we try to find those values after solving the system. Okay. So this is an example, and by the way, these examples are taken from your textbooks. Okay. So we are actually taking, the references are over there. So we're taking from your textbooks. So whenever we're solving that particular section, we will be solving those equations. So this is a system of equations. Okay. You have learned in your linear algebra course about the system of equation, how to solve system of equations. But in this course, we will try to see, okay, whenever the solution is an irrational number, how to deal with the system of equations. Okay. So that system can be linear, that can be non-linear. The equation you just see in the previous slide, in the problem 1, that was the non-linear equation. That is not the linear equation. Here you see these are the linear equations. Okay. But the system of equation can also be non-linear. So the second topic of our course will be how to solve the system of equations. Okay. That system can be linear, that system can be non-linear. Okay. Going to the third problem. The third problem is about a data you see. So you have certain observation of a pressure against the temperature. Okay. So maybe you have done an experiment, or you have noted down information for the particular experiment, and you have this information, and you wish to find the pressure maybe at the 25 degrees Celsius, which is not available in this table. Okay, maybe you wish to find the temperature at the 70 degrees Celsius, or maybe you wish to find the temperature at the 110 degrees Celsius. Okay, so if you wish to find the temperature at 25 degrees Celsius or 70 degrees Celsius, these two information are within the range of the temperature we have, that is from 0 to 100 degrees Celsius. Okay, so we try to predict what is the value of the pressure at 25 degrees Celsius or 70 degrees Celsius. That is not information available in this table. So in this course, the third topic will be how to predict the values that are not available in that particular data. Okay, so whenever I try to find the information at 25 degree or the 70 degree that lies between the ranges of the temperature, that is 0 to 100, the techniques are interpolation. So interpolation techniques, the prediction are, and if I try to predict at the 110 degrees Celsius, so it is an extrapolation. Okay, so we try to predict either within the range of the independent variable, which is temperature in this case. So that is an interpolation technique, and if I try to predict outside the range of the independent variable, that will be extrapolation techniques. So that all comes into the topic of prediction, or I can say curve fitting. We try to fit a good curve within the data, okay, and I try to predict the information at the points which is not available. Okay, so it is very helpful. It has many implications, and I'm not going. Will be once we're seeing those topics, we'll be in extensively seeing those. Okay, so our third topic will be the curve fitting. Okay, that's our third topic, and this problem, from this problem you can also learn. Maybe I wish to find the change in the pressure, maybe at the 20 degrees Celsius or a 25 degrees Celsius. Change in the temperature. Okay, so now if I wish to find the change in the temperature, it means I wish to find the derivative. Okay, how the pressure is being changed with respect to the temperature. Okay, since I do not have at this point any function of the pressure that is give us the value if I feed the temperature, so it is hard to go to find the change in the temperature. Okay, but in this course, first we will be fitting the curve, and then from that curve we will try to see what is the change in that curve. uh, so to understand or to know the value of the change in pressure at the temperatures, whatever the temperatures may be, that is at 20 degrees Celsius or 25 degrees Celsius or 110 degrees Celsius. Okay, sorry. So we will be seeing the uh, differentiation in terms of whenever we have a data. So that topic will be numerical differentiation. Okay, coming to the next problem, it is about the heat flux of the pipe. So in a heat conduction problem, this is the equation that we have, and if you see, there is an integral involved. Okay, and if I ask you to solve that integral with respect to the variable x, you'll see a lot of trigonometric functions. Okay, or both in denominator and numerators. Okay, so and you have also learned from your previous studies that you encountered certain integrals which are not easy to solve. First thing, and second thing, which are not integrable. So both things are there. Okay, whenever the integration comes, it takes certain time to evaluate an integral. Okay, so whenever the internal function that we wish to integrate is becoming complicated, so we have a difficulty in solving those. So in this course, our topic number actually, so the first topic is a one variable equation, then we have a system of equation, then we have curve fitting, and then we have numerical differentiation, and the fifth one is numerical integration. Okay, so how to solve the integrals if they are not integrable or they're difficult to integrate. Okay, so that will be the challenge that we'll be seeing and how to deal with that challenge, we'll be seeing in this course how to solve those issues. Also, if you go back to the problem of number 3, for example, if you wish to find the integral, you want a cumulative pressure maybe from a temperature 20 degrees Celsius to 60 degrees Celsius, what are you going to do? Anyone? So we will be solving. So there is an answer. We will be solving an integral because integral sums up the information, na? Okay. So and there is no function available. It's just a data. So we will also in the next topic we will be also seeing if we only have the data available and we wish to accumulate the information from a certain point to certain point, how can we do that? Okay. So in generally we'll be dealing the integration in numerical terms. Okay. In approximate terms, we wish to find the approximate that integral. Okay. And coming to the next, this is the differential equations. So in design of a sewage treatment plant, this is actually the equation we have, and here H is the level of the fluid in an injection chamber, and T is actually the time. Okay, so if you see this equation, this is a differential equation, and if I try to solve through the method we learn in the differential equation course, and if I am not able to do that, I need certain methods by which I can at least find an approximate solution, okay, or nearest solution. So in this course, we will be also looking to the differential equation, and specifically, we'll see once we go to the differential equation what are the classification available. So, but we will be solving the ordinary differential equation. You'll see this is an ordinary differential equation, okay, because there is one independent variable which is the time, okay. And in the next problem, you will see a partial differential equation. So this is also called a heat equation. Whenever there is a heat source, we can formulate a heat equation. So this is a heat equation that we develop. U is actually the temperature in that maybe a one-dimensional rod you can see as maybe a pipe. Okay, so and we wish to find the temperature at any point. So there may be a fluid passing through that pipe. Okay, and there is a temperature distribution. Maybe some heat source is at the inlet or maybe surrounding the pipe. Okay, and so there will be a change in the temperature inside the pipe. Okay, so the modeled equation is a heat equation, and we'll try to see how to find the approximate solution once we're not able to find the exact solutions. If we're not able to find the exact solution, we try to find the approximate ones. Okay, so how to find the approximate solution once we're dealing with the partial differential equation. So it means this is our course. Actually, we will be just seeing the equations in the numerical in an approximate way. Okay, so if I just summarize the information, you can see that starting from the one variable equation. No, can you go to the next slide? Yeah. So this is actually our course contents that I already shared with you. Starting from the one variable equation to the system of equation, and then to the curve fitting, numerical differentiation, numerical integration, solution of ordinary differential equation, partial differential equation, and all this in an approximate way. When all the exact method fails or they are challenging enough to give us the answers, then we go toward the approximate one. At least we have an approximate solution. And whenever we are trying to solve the approximate solution, we come up with some error. As if we wish to have an exact value of a root 2, we can't have it. We just can approximate it up to certain decimal place. Okay. So this is the course contents, and to achieve these course contents, these are the defined learning objectives. Okay, in your course there are 3 objectives. First is there will be an error involved. You are familiar with the outcome-based education system. Okay, so we have defined based on the contents 3 actually learning objectives of this course. First is whatever the error is involved, we need to quantify that error. how much are we getting in the approximations. And the second our learning objective will be, we will be learning different algorithms, how to solve, how to understand those algorithms. And the third objective will be how to deploy actually those algorithms into the computer systems. Okay, so we'll be using the MATLAB for the computer systems. Okay, so to achieve obviously these learning objectives, um, we will be having all the assessments available with you. Okay, we will. I encourage you to ask questions. Okay, ask as many questions as you can, but the relevant one. Okay, be humble to your peers, to your all your colleagues, and to the class environment. Okay, so this is the actually the overview and actually the motivation, or actually the problems we're going to see in this course. Okay, so to wrap up this lecture, uh, we just seen in this lecture that what are the requirements. Okay, what is the main content we're going to follow. Okay, so and in what is the content and what is actually the learning objective of this course. And I expect from you a very important thing, that is the timely submission of the assignments and the projects. Okay, and try to use the softwares, try to use the chat gpt or any versions that you have. Okay, try to use that and to understand that. So whenever you're trying to submit any information, try to understand that. If you understood that, that would be fair enough, no issues. Okay, but don't just um, submit an information without any references, without any citation if you have taken somewhere, or without using any tools you're using. Okay, you have to declare any particular tools you're using to the information. Okay, and I have also given in detail any information in um, the uh, the information I've sent you about the course syllabus. You can go through that. Okay, so in the next lecture we'll be seeing the mathematical preliminaries which are required to continue in this course. Okay, thank you so much.